today's video, I would like to introduce a very nice problem of African Mathematical Olympiad Mozambique 2003. Here is the following information. Find all positive integers n such that we have this setup 2 to the 2n plus 2 to the n plus number 1 is divisible by 21. Okay, in fact this is very nice and interesting problem to work on. They tell us 21 divides this term. We are going to find the appropriate values of this where we have a divisibility occurred. Okay, so I will recommend to give that try to this problem prior getting to the solution. Go ahead, pause this video when we come back to see the full solution. Okay, now let's jump into the solution. 21 is the same as 3 is multiplied by 7. So this one I have a factorization prime here. Let's set capital N equals this term 2. So they told us we have 21 divides capital N. This one equivalent capital N, which equals 2 to the 2n plus 2 to the n plus 1 is congruent to 0 mod 21. Okay, this one equivalent capital N is congruent to 0 mod 7, and also capital N is congruent to 0 mod 3. Okay, in the other word, 21 divides this term. That means 7 divides this term and 3 divides this term. Okay, now this one is already reduced to the mod 7 and mod 3. Okay, I'm going to work on the second equation where we can find the solution when we have n is congruent to 0 mod 3. Let's break this one into two cases, when we have n is odd and when we have n is even. If n is odd, we'll have capital N, which equals 2 to the 2n plus 2 to the n plus number 1 is congruent to minus 1 to the 2n plus minus 1 to the n plus number 1. As we know, this one is arithmetically turned into 1. This one, when we have n is odd, this minus 1 to the n becomes minus 1. This one plus number 1, this one is congruent. Minus 1 and 1, they will be cancelled out. I will be left with 1 is congruent to 1 mod 3. Okay, this one equivalent 3 not divides capital N. Okay, that means we have no solutions for odd numbers. Okay, no solution if n is odd. Okay, now let's check when we have n is even. N is even. I'm going to write this one as it is. I have capital N equals 2 to the 2n plus 2 to the n plus 1 is congruent to minus 1 to the 2n plus minus 1 to the n plus number 1 is congruent. This one is arithmetically towards 1, but this one, since we have n is even, becomes 1 plus 1 plus 1. 1 plus 1 plus 1 is giving us 3. Okay, that's mean this one is congruent to 3 mod 3, which is congruent to 0 mod 3. Congruent to 0 mod 3. This one is telling us equivalent 3 divides capital N. So that's mean now we have a solution when we have n is even. So now I know n is even, we have a solution. Let's move on to the previous one. We know 2 to the 3 is congruent to 1 mod 7. Okay, I'm going to multiply both sides by 8. Okay, 2 to the 3 is multiplied by 2 to the 3, which equals 3 is multiplied by 2. Here is what was multiplied by 1 here. This one is congruent because I have multiplied both sides. I multiplied both sides by 2 to the 3. This one is congruent to 8. Since 8 is 1 more 7, I will get is congruent to 1 mod 7. Okay, again I'm going to multiply this number by 2 to the 3 again. So we'll have 2 to the 3 is multiplied by 2 to the 3 is multiplied by 2, which is this one, equals 2. This one, 3 is multiplied by 2, 6. 6 plus 3, which is 9, which is the same as 3 is multiplied by 3. Okay? Is a congruent to 8, which is congruent to 1 mod 7. Okay? Now this one is going in the same pattern. If you take a look at the exponent is going on this pattern. 3 is multiplied by 1, 3 is multiplied by 2, 3 is multiplied by 3, and so on and so forth. That means this one will be written on this form. This one is telling us 2 to the n, it will be written on this form, 2 to the 3k, which is congruent to 1 mod 7, whereas k is a sum positive integers. Okay, so I'm going to keep this one. Now we found n equals 3k. Okay, I'm going to check if n equals 3k is going to be provide this divisibility statement or not. Okay, so I'm going to replace 3k into this setup. So we'll have capital N equals 2 to the 2, 3k plus 2 to the 3k plus number 1. So I'm going to reduce this one to mod 7. I'm going to visualize this one. I will have 2 to the 3k to the 2 like this, plus 2 to the 3k plus number 1. If I'm going to reduce this, if I'm going to reduce this one to mod 7, this one is a congruent to 1, so this one is a congruent to 1. So the total I will have, this one is a congruent to 3 mod 7. Okay, this one is starting at 7, not divides this capital N. Okay, so previously we have this number as a capital N, equivalent 21 divides N. We found if N equals 3k, 7 not divide N. Okay, since 7 not divide capital N, and 21 is a multiple of 7. Okay, so that's mean the smaller number is not divide N, so that's mean the bigger number, which is 21, is not going to divide N. Okay, so it's telling us 21 not divide N, because 7 not divide N. Okay, so this is on one side, and also we have proven N is a even. Since 21 not divide capital N, that's mean this capital N is not multiple of 3, because we found if we have N equals 3k as a solution, equivalent implies 21 not divide N, that's mean capital N is not a multiple of 3. Since N is a even, it's not necessary to have N equals to M as a solution, because this one is the expression form for the even number. Okay, but the solution is not going to write on this form, because if the solution is going to write on this form, you will include this solution here, because if M equals 3 or 6 or 9 and so on and so forth, you will not have a solution. Okay, this one is going to be out of this solution. Okay, previously we have proven this one, 2 to the 3k is a congruent to 1 mod 7. Okay, so I'm still working on mod 7. Okay, since N equals 3k is not a solution, and this one is a rolled out of this possibility as a solution, I'm going to put if N equals 3k plus number 1. Okay, I'm going to check this one, it may be a solution or no. Okay, so I'm going to insert this value of N into this setup by reducing this one to mod 7 to see what's given us. Okay, so we'll have capital N equals 2 to the 2 is multiplied by 3k plus number 1 plus 2 to the 3k plus number 1 plus number 1. I'm going to visualize this one by writing this one as 2 to the 3k plus number 1 to the 2 like this, plus 2 to the 3k plus number 1. Okay, plus number 1. I'm going to extract 2 to the 2 out of this one. I will get 2 to the 2 is multiplied by 2 to the 3k to the 2 like this. Okay, plus also I'm going to put number 2 is multiplied by 2 to the 2 to the 3k plus number 1. Okay, this one is a congruent to mod 7, is a congruent to 1 mod 7. This one also is a congruent to 1 mod 7. So I will have here 2 to the 2, which is 4. 4 is multiplied by 1, which is 4. Plus number 2, 6, plus number 1, which is 7. This one is congruent to 7, which is congruent to 0 mod 7. Okay, this one equivalent 7 divides capital N. And also previously we found 3 divides capital N. Okay, if N is even, both these statements is telling us 21 divides capital N. Okay, if N is even. Okay, if we have this condition, we have N equals 3k plus 1 as a solution. That means this one is a solution if is even. Okay, if this one is even. Also k must be odd. Okay, in this case, because if k is a odd is multiplied by odd is given as odd, plus number 1 is given as even. That means this one is turned into even if k is odd. This one is a solution. Okay, let's check if N equals 3k plus number 2. So I'm going to do the same job by inserting this one into the original one. So I will have capital equals 2 to the 2 is multiplied by 3k plus 2 plus 2 to the 3k plus 2. Okay, plus number 1. So what I'm going to do now, by taking 2 to the 4 out of this one as a factor, I will have 2 to the 4 is multiplied by 2 to the 3k square plus 2 to the 2 is multiplied by 2 to the 3k plus number 1. Okay, I'm going to check. This is a congruent. As we said before, this one is a congruent to 1. This one is a congruent to 1 mod 7. This one also is a congruent to 1 mod 7. I'm going to calculate this one. So 2 to the 4 is a 16, is multiplied by 1, stays 16. This one is 2 to the 2, which is 4. 4 plus 16, which is 20. 20 plus 1, which is 21. 21 is a congruent to 0 mod 7. Okay, so this one is telling us 7 divide capital N. Since we have 3 divides capital N, this one is telling us 21 divide capital N if N equals 3k plus 2 as an even number. This must be even as well. In this case, k must be even in this case. Okay, because even is multiplied by odd is given as even. Even plus 2 becomes even. So I'm going to summarize this one. So we have two solutions. We have N equals 3k plus 1, whereas k must be odd, and N equals 3k plus 2, and k must be even. Okay, whereas k is a sum positive integers. We found two general solutions. We have N equals 3k plus 1 if k is odd, and also we have N equals 3k plus 2 if k is even. So I have done this problem. If you are interested in this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.